Hello and welcome to another edition of Elektor Engineering Insights, coming to you live again from Johannesburg in South Africa. And today we have an exciting guest joining us. It's the bold engineer himself, James Lewis, otherwise known from his YouTube channel as Add Ohms, but he also does stuff all over the place. He's got his own blog, he's on Discord, he's on Element 14. And James, how are you doing today? Coming to us live from Chicago.
Yeah, live from Chicago. Hey, Brian, I'm doing great. Thanks for having me on.
Oh, that's awesome. We've been wanting to have you on for a while because you've got so much interesting content out there. I don't know how you'd find that many hours in the week to get all of that done. Your videos are very in-depth, and I can only imagine the hours that go into that. James is known for his expertise in electronics and his educational YouTube channel, as I said, at Add Ohms, ADDOHMS, and his popular blog at boldengineer.com. So today we'll dive into his journey as an engineer and discuss some of his most intriguing projects, and we'll explore the tips and tricks he's picked up along the way. So whether you're joining us as a seasoned engineer, like I see some of my friends in the chat are, or you're just starting out, there's sure to be something for everyone. James, welcome to the channel. And first of all, let me ask you about the different monikers you go by. Bold engineer is what we've been calling you. Some people like to stay anonymous, but not you, so I can call you James as well, James Lewis. But you've also got Add Ohms. Why the different name for your YouTube channel?
Yeah, so years ago, so my first and last name is super common. And so back when I was trying to think of what could I go by, I was trying to figure out a good name. And I figured since I was bald and an engineer, that would work. And I started signing up for social media platforms with that name. And the only one I didn't try was YouTube. And it's because when I decided to create a YouTube channel, I wanted something that started with the letter A. And then by the time I realized I should have gotten Bald Engineer on YouTube, somebody else had already taken it. So that's how I ended up with Add Ohms, which is interesting because a lot of people that only know that channel think my name is Adam, which it took me a while to realize it's because Adam and Add Ohms sounds the same, but it wasn't anything like that. I just wanted something electronics related and starts with an A.
Well, now that you mention it, Add Ohms does sound a bit biblical. I do feel your pain, however, because my first and surname is Brian Williams, and that's what I went by until the internet came along and nobody could find me. So I had to also differentiate. So at least you'll find me under this name, even if it's a bit long. I'd like to tell the audience now about our giveaway, which we'll go into later. Let's put that up on screen. It's the Practical Electronics Crash Course Bundle, which, if you want to get started in electronics, it's easier than you might think with this Practical Electronics Crash Course Bundle that we are giving away. We're giving away 3 of them, and it includes a comprehensive book and a complete kit of parts. I mean, there's a component list there. It's quite in-depth. And the bundle allows you to explore and learn key electronic and electrical concepts through fun hands-on experiments without complex jargon or long calculations. You'll have everything you need to build the examples in the book and start creating your projects in no time. And in the next tab, I'll just bring up the giveaway page. It's elektormagazine.com/elektor-engineering-insights giveaway. As always, there's a code word to put in here, which I'm not going to give now. We always tease that until later. But yeah, that's the place to go. We've got the bold engineer with us. And let's take that off the screen and get back to our conversation. So, James, I'm more of a digital guy. Stuff either works or it doesn't, especially back in the day when digital was low frequency, so we didn't have to worry too much about RF interference and stuff going on. Although I did find your content on the Apple, the pulses, some of them had this weird analog glitch, which you said was intentional. And that obviously throws back to you being so good with oscilloscopes and capacitors, which to me are fundamentally analog, but obviously they helped you to pick out the stuff.
Yeah, actually, it's funny because in college, I was a TA for an analog professor. The RF classes are what I enjoyed most. And my first job out of school was a digital application engineer. except I spent most of my time with our high-end oscilloscopes, and back at the time, probing stuff like PCI Express and other things in the gigabit or gigahertz range. And so I always considered myself a digital person, but a lot of my work has been in the analog world. And so, yeah, so to kind of bring those two things together, scopes and capacitors, about half my career I dealt with high-end oscilloscopes, and about half my career I dealt with capacitors, professional career, dealt with capacitors and other passive components, which sound like complete opposites, but despite their size, they have almost the same amount of complexity, just in different things.
Well, that's something you certainly know a lot more than I do about in that field. I'm still getting to grips with an oscilloscope that I have here, which is a green CRT. I joined that party about 30 years too late, but I always needed one. They were always so expensive. I resorted to things like capturing from the PC parallel port as fast as I could. And, I did get some insights from that, and it was free except for my time. But yeah, to get to an actual oscilloscope back in the day, 10 megahertz was enough, even if you were working on PAL or NTSC signals with their 6 megahertz bandwidth or so on. And you've you've worked on Apple IIe. Let me just bring that up as well. This video that you made was fascinating. It's a first fully functional computer built around the Apple Mega 2 chip. Now, my father had an Apple IIe when I was a kid. I had my Texas Instruments TI-994A, which was the toy which you plugged into the TV, while the real computer, the IIe, he was using to study a private pilot's license, and it was on the desktop in the living room. And
Nice.
What made you get so hooked on the Apple IIe?
So this all started about 10 years ago. I had just started getting back into retro computing. And so basically I was starting to get into this mode of I wanted to start recollecting the 8-bit computers that were around when I was growing up. And so I had a couple of Commodore 64s and VIC-20s because that's what we had a VIC-20. One of my friends had a Commodore 64. Those are the computers I remember people having at home. But through all of the elementary schools that I went through, we always had an Apple II. And so I was like, I think I'm going to buy an Apple II GS because it can run Apple IIe and Apple II software. And plus it does a whole bunch of other cool things on its own. And so I did, and then immediately realized I couldn't remember how to use an Apple II. Like I didn't even know how to boot from a disk if it didn't auto boot. And so I went out looking for a manual, and I was like, I found the hardware reference manual for the Apple II GS. Being a hardware guy, I was like, hey, that sounds like something that would be the right thing for me to start with. And in that, I found out about this Mega 2 chip, which contains all of the logic of an Apple IIe on a single ASIC. And so that led me to thinking about some questions and eventually the project that we were just looking at.
And this Mega 2 chip, was it something that they had specifically for the GS, that they reduced component count and so on?
Yeah, so what's really interesting about that is it was never actually intended, from what I can gather, it was supposed to be put into a follow-on to the Apple IIe. Well, so they did the Apple IIe, then the Apple IIc, and there was going to be a low-cost Apple IIe, which would make use of the Mega 2. And because basically the Apple II line went from 80 chips in the Apple II to like off-the-shelf 80 off-the-shelf chips in the Apple II to 4 or 5 custom chips in the Apple IIe to the Mega 2, which was essentially the single custom chip. However, that project, from what I understand, got canceled, and so it ended up in the 2GS because they needed something to act as the I/O controller so that they could use basically Apple II expansion cards. There is a little bit of a misnomer, and Apple is part of the reason why people believe this. The Mega 2 is actually not the primary thing that makes the 2GS backward compatible. In fact, it only really does 2 things in the 2GS. It handles Apple II video modes, and it interfaces with hardware. The vast majority of the Apple IIe logic is unused in the 2GS. It's all of that stuff is actually implemented in the 2GS's own chipset.
Oh, wow. So was there ever use for all of that extra stuff that was unimplemented in that particular instant?
No, so the 2GS didn't make use of it. However, there was a computer called the Tiger Learning Computer that Tiger Electronics partnered with Apple. And that did actually build a 2E compatible computer around the Mega 2, but it had its own ROM and it never made it out of test marketing. And then there was a couple of other like products that made use of the Mega 2, but none of them were like an Apple IIe computer. Yeah, there's only a handful of these
Tiger
learning
Learning computer.
Yeah, there's only a handful of these out there, and the one, from what I understand, the ones that are out there don't work very well.
Oh, really? Kind of reminds me of the Tomy tutor and stuff like that, which used a lot of components from bigger brother computers and that sort of thing.
Mm-hmm.
So now you are trying to preserve this heritage. You've got Bit Preserve. Let me bring that up. There we go. Introducing
Yeah.
Bit Preserve, and you talk about creating a portable Apple II. Could you tell us a bit about that?
Yeah. So BitPreserve actually came before the Apple II project. And back when I started BitPreserve, I still had this idea of building a portable Apple II around the Mega 2. But eventually I just gave up on the portability thing because I realized the games for the Apple II are not as fun as I thought they were. And I had more fun playing with the hardware. But BitPreserve was a project I started to redraw and redocument vintage computer schematics, because the number one problem I was running into is there's lots of PDFs of schematics for computers up until maybe the mid 90s, but a lot of those scans are not all that great, and you can't really do anything with them other than look at them. And so I decided to start redrawing. I started with the 2GS. I redrew its schematic in KiCad. And then that led to other people wanting to contribute schematics for other computers. And so now I want to say there's probably at least a dozen computers plus a handful of variants for several of them that are in the archive. It's basically just a GitHub repo that people can either submit a pull request if you want to add a schematic, or download it and make use of the ones that are there.
Cool. And to recreate some of these things, did you have to desolder components from the boards, or did you just go by the schematics that you had from the manufacturers?
So I've done a mix. So me personally, most of the time I'm just redrawing from the schematic. There's been a handful of times, like when I did the schematic for the Apple IIc monitor, which was this 9-inch green CRT. It's really cute, really sharp, fantastic display. That one, I did use some measurements to figure out what some of the components, like some of the inductors were. And then there have been people who have done a little bit of reverse engineering work on the circuit boards. That's something I haven't really gotten into, but I can see where there's a lot of interest in doing that as well. I was just focused on the schematics, but yeah, I think recreating the circuit, or trying to document what some of these circuit boards were supposed to look like, I think is also a very helpful task.
Yeah, what I did, and I think I told you about this, I'll bring up a desktop over here. And what I did is my first computer was this Texas Instruments TI-994A. And I also decided maybe 10 years ago that I wanted to, recreate the board like to its authentic self. So if we open up inside, you'll see the actual motherboard is this here. So now, only recently did I get this. Yeah, it's a 16-bit data bus and 15-bit address bus, because each address is full 16 bits wide. So it's 64K.
Mm-hmm.
What were you going to say? You didn't realize?
So I didn't realize the board was so small. And then I was going to say, isn't this the one that TI had like this funny 16-bit chip that was kind of a hybrid of a 16-bit and 8-bit processor? Like the TMS.
Well, it's
something.
Yeah, it's a TMS 9900, and it is a full 16-bit chip, but it only addresses 64K of RAM because it has a 15-bit address bus. And as I said, not a 16-bit address bus, because every memory reader's. But there's a lot of weird things about this computer. For example, it only has 256 bytes of RAM. So you're like, how do you get away with that? Well, the BASIC and everything uses the video RAM. Every everything that happens in BASIC has to go via asking the video chip to store stuff.
Interesting.
So anyway, I've got a few of these. I've had a few, and I still have them because I'm a hoarder and never throw anything away. So when I was young and dumb as a teenager, I used to blow them by experimenting. And then I heard about solder reflow ovens. So I thought that would be a nice way to get the components off. But then I found out that microwave oven is not exactly the right tool for the job. So that's what I ended up with.
So that looks like the first PCB I tried to reflow in my toaster oven. I wanted to see if my toaster oven could get hot enough to reflow solder, and so I didn't even have a thermocouple or anything. I just turned it on as high as it could go, and I wanted to see if solder would reflow. And then what I didn't realize is that there was a massive amount of carryover. So when I turned the oven off, it kept heating up, and the board eventually started smoking. So for like a week, my apartment smelled like, well, it smelled like burnt circuit board, which I think you'll know what that smelled like because mine kind of looked like that.
Oh yeah,
yeah,
for sure. It smelled very toxic. So I'm still here though. I don't know what the long-term effects were. And then finally, when I got a bit older and wiser, I've got a vacuum desoldering tool. So finally, I managed to get a board out. And then I tried to remake this, but not in KiCad, in I think it was Eagle at the time, because it was about 10 years ago. And I found that the components didn't exactly match the grid that was available, probably because the stuff was all laid out by hand. But, we obviously share a passion in restoring or at least preserving the heritage of these things, which you went to great lengths. I would recommend this to our audience. If you see the title there, Preserving History with KiCad, James Lewis. Definitely have a look at that.
Yeah,
are you still up to this stuff, James?
Yeah, so I took a break because the summer has been busy, but I normally, for a while, I've been streaming on YouTube once a week doing bit preserve schematics, primarily just because I want things documented for myself. But I think there's a lot we can still learn from these older computer systems simply because a single person can understand them from one transistor in the processor all the way up to a dot on the screen. And all of the fundamental blocks between those two are essentially what we use today, just with tons of complexity on top. And so, while, sure, you're not going to get a whole lot of work done on an 8-bit computer today, I still think it makes sense to understand how they work because they actually do give you a really good blueprint for how a lot of stuff that we use right now works. I mean, just look at microcontrollers. I mean, all of them, other than like security stuff, modern microcontrollers have all the same fundamental blocks that an 8-bit computer had.
Yeah, true. And I also discovered that late in life because when we first got these microcomputers back in the 80s, we went from the top down. We got this box, and then Commodore 64 had this BASIC, and the TI had this BASIC, and we were very competitive, and my computer was better than yours, and we basically worked the way down. But like the BASIC you got, that was completely arbitrary. That was written for that machine. But as I got deeper and deeper, eventually I learned how assembly works, and I even had this microprocessor. I only got to this in the late 90s. I'll bring this up on screen. This probably came out in 1980, 1981. And, this thing is a computer, but it's not a PC, and it does not connect to a PC. So to write your code, you have to assemble it with pencil and paper yourself. And that was a great learning experience for me. And it taught me that, deep down, whether you're an Apple guy or a TI guy or a Commodore guy, they're all the same fundamentally down at the chip level, and everything else outside that is just cosmetics. And that just makes all of them interesting too once you know how the CPUs and the chips work down at that basic level.
Yeah, I was gonna say it's funny because I've got a couple of friends who we kind of rib each other, like especially a friend of mine that is into Atari computers. For some reason, he labels me as somebody that likes the Commodore, and I do, but I definitely enjoy the Apple II more. However, I appreciate all of these computers, right? I mean, it's I don't think any of them are better than each other other than certain aspects of them. But I absolutely remember back in the day thinking, yeah, well, if you don't have a Commodore 64, you don't have a real computer, right? And it's like, yeah.
Yeah, I remember those days. Now, like I say, they're all fascinating because now when I look at a manual for a Commodore 64, I know what a memory map is and I know what a 64K address space is. So it makes sense now. Looking at what Frank DeHart says here, the junior computer was great for learning about computers. I'm not sure if you mean this one here, Frank, the Elektor junior computer. But yeah, as you see there,
cool.
it's a hexadecimal keypad, just like this other one that I mentioned. This is hexadecimal, yeah, and you had to key the code in. And again, a 7-segment display. So yeah, pretty much a very similar thing. Although I'm not sure what CPU that junior computer from Elektor had. 6502, okay. Very common CPU there, and a very nice and simple one. I like the 6502 as well.
Yeah, well, that's well, especially with the demise of the Z80, the 6502 is probably going to become the most prominent 8-bit processor.
Yeah, although this is a Z80, and
or
you see on there, I put
sorry.
a sticker on. Yeah, ZZ. I mean, I've got to say solder, aluminum. I put a sticker on there so that I could see, you know, the whole bus myself.
The pins.
Obsessive
Nice.
people we are, I think. Put that away. And 6502, there are still Z80, Z80 variants running around, but they're much more complex than the ones from those days. Let's see what else is happening in the chat. Baltic Lab says hi. Hi, Sebastian. Thanks for joining us again. And hello from Gustavo. He says, greetings, James.
Gustavo, always good to see you pop up.
Great communities where we see the names come up and we Pratt H, fun, nice to listen to while I work. Well, I hope we're not distracting you too much. Depends on what you're working on. If you're cutting hair, you'll probably be okay. Question. Let's do a question from MS21Z. What's the latest project you did which we don't know of? You don't have to give away any secrets.
Yeah, so I did a couple. I've worked on a couple of things that I didn't finish. Let me just, so this was a project that I really wanted. I want to come back and do this at some point. This is I'm calling it a universal keyboard adapter. I found this chip which was meant for security cameras, but it's basically a switch matrix. So right now you can plug this onto a Commodore 64 header, and the Pi Pico can emulate its keyboard. So the idea was I want it to be able to connect either by Wi-Fi or over USB and type with a PC on a Commodore 64. And then my long-term goal is to make this compatible with other 8-bit computers to replace their keyboards. Because one of the things I hate when repairing a vintage computer is having the keyboard and everything on my table. You know, I almost always have a laptop or a PC, so why can't I just use that computer? So that one, I worked on it for a while, and then that got kind of sidelined. I've been working on this series of, I'm going to call them pointless adapters, but they're actually super useful. So they have banana connectors to go into a power supply, and then I'll have standard standard ports. So I've got this USB one, and I've got one for USB-C, a barrel jack, and screw terminals. I created these because of two reasons. Number one, I wanted to learn how to make a PCB that you break apart and then solder back to itself, which is the answer to the question of why don't I just use a vertical USB? Well, number one, I don't have any, and number two, then I would need verticals for everything else anyway. And number three, I wanted to see if I could figure it out. But yeah, so that's actually something that I'm working on that, and I've got a video coming for that. And then I won't show it because it's not mine, but I have been working with a retro style computer. It's actually got a Z80 and a 6502 built, combined together with some modern CPLDs. And so I'm doing some content around that. So I'll say on that one, people just have to stay tuned. I've designed a couple of things to plug into that, and I'll show off that computer in a
video coming up very soon?
Well, that's a perfect question asked by Jesus there, Z80 or C6502. It sounds to me like you like both of them.
Yeah, I definitely know the 6502 better, but the Z80 is definitely a great processor. I don't know it as well. The Apple II project, or I call it the Mega 2 project, it really caused me to learn how the 6502 works. I spent so much time looking at 6502 assembly code that I understand the chip really well now, or at least I think I do.
Yeah. And then I've got an excuse to bring this out again, my TI-994A, because this chip here underneath the thermal paste is the TMS9918A. Now, in 1979, they released the TMS9918, which didn't have a bitmap mode, but that was for the TI-994. In 1981, they released the TI-994A, which is named after this chip, the 9918A. Now, the reason I bring that up is because that became kind of an industry standard, 256 by 192 resolution with 15 colors plus transparent. And the question here from Danny Liebert is, what about the MSX computer? Yeah, the MSX line of computers such as the Spectra Video range, and there were a bunch of others, I think Sanyo, MBX, I can't remember them all. But yeah, that was the video chip that they used in that line as well. So theoretically, well, not even theoretically, practically any image you could show on a Spectra Video or any of the other MSX line of computers could be shown on any of the others because they had the exact same graphics chip. Do you have much MSX experience, James?
You know, it's on my wish list. Before I left the corporate world, I was going to Japan on a very regular basis, and I kept eyeing MSX machines in the various resale shops, and I never bought one because I could never find one that seemed like it was the right mix of cool and ability to fit in my suitcase. And so that's my one regret in all my Japan trips is I didn't pick up an MSX. I would really like to spend some more time with that machine or series of machines. It's an interesting, the whole story about how they came about and how they got built and then their architecture. I just think it's really fascinating.
Yeah, if I look around me now, I've got a few TIs, I've got a C64, I've got a Commodore Amiga, I've got a ZX Spectrum. But one thing on my bucket list is to get a Spectra Video because that was one of the MSX machines, which I've never had. Another question here from Roland. Did you have a look at the new Retro Agon Lite 2 computers? Now, I've never heard of it, but I did take the opportunity to Google that quickly. That's it there. Now, apparently it's Z80 based with BBC Basic, but it's modern retro style. Have you heard of it, James?
Yeah, I have. I looked at it and it looks interesting. And if I was looking to get into the Z80, like specifically, I would probably consider it just because it is modern. And I mean, BBC Basic, from what I understand, is one of the better basics. And that's actually, it's one that I have very little experience with. So it's something I would actually, that aspect I'm more interested in. But yeah, I remember when these came out and it seemed like these were relatively popular. But I didn't. Oh, it is from Bernardo. Okay, hold on. Okay, so I didn't. I wasn't going to show it because it's not mine. But since we're talking about Argon, so the person that created the Argon 2 created this computer, and this is the one that I was hinting at. And this is called the Cerberus. Let's see if I can get rid of the glare. And so the Cerberus has. Let me make sure I get this right. Point at the right chips. So this computer has a 6502 and a Z80 on it. And then there's a couple of CPLDs that tie those together as well as generate the video. Now you can't use both of these at the same time, but the computer is designed so that you can switch between them. And so like the 6502 has its own basic and the Z80 is running BBC Basic. And so this is actually, I don't know the exact timeline, but this is kind of a follow-on to the, I keep wanting to call it Argon, but I think it's Agon. But it's a follow-on to that computer. Same person designed this one. And so this is actually, to me, a really cool way to go because this solves the Z80 or 6502 problem. You have two processors connected to essentially the same bus, and so you sort of remove the computer architecture from the equation, and you can focus on one processor or the other. And so he sent me one of these. I'm doing some video work. I'm doing a video on them. I really like it. It's a really fun computer to play with. Highly recommend. Especially.
Yeah, and I hadn't heard.
Sorry, I was just going to say, especially before the Z80s stopped becoming available.
Yeah, I hadn't heard of the Agon, so I also thought maybe it was a spelling error, but yeah, it is indeed Agon-like 2. Okay, I think we can go now to our giveaway, which I mentioned earlier. Put it up here again. That's the page to go to. And if we can get the link up on the screen. There we go. elektormagazine.com/elektor-engineering-insights giveaway. And the code word, which we promised, is Baldy. But it's not Baldy as the normal way you would spell it. It's Bold EE, which James tells me stands for Bold Electronic Engineer.
Yeah, it's actually how I
So
like
there
to
you go.
shorten my name when I go places.
Ah, cool. Let's see that again. I'll take this down so I can have a better look.
No. Keep your giveaway up. It's just I made a PCB
Cool.
name badge. That's all.
You need e-ink on that, right?
Yeah. Hopefully, I'll do that in a future version.
Okay, so we wish you all good luck if you're entering the competition, especially if you need a startup. I think some of you should be disqualified, like Sebastian from Baltic Lab. It is way too simple for you, but it's a great startup. So now, James, if I could ask you about some other project which I found very interesting, and I'll bring back to the screen, your Bold Quarter.
Yeah.
I'm taking it you were a Star Trek fan?
Yeah, why would you think that? I can't imagine. Yeah, so this was
was that just a flight of fancy?
Yeah, so this was it was part of a contest that a couple of other creators and I were doing. We were given the same, I think it was 5 basic components, and we all had to create a project around it. And and I don't remember everything that was in it, but there was like an Arduino Maker 1000, an OLED screen, like a 128 by 64 pixel OLED, a time of flight sensor, or it could be used for proximity, distance, or gestures. And then there was a IR detector. And so it was basically, it was like IR, an IR LED and an IR detector, and then there was a slot, and it was supposed to, you normally use it to like detect like an end stop or something. And so the goal was to build the most unique project out of those 5 basic parts. And I had one project idea that was really dumb, and at the time I had a Star Trek tricorder toy sitting on my desk, and I was like, well, you know what? There's the display, and there is the microcontroller. There's the time of flight sensor. And then I was like, well, what if I could turn that IR sensor into a light sensor? And so I ended up basically making a really basic tricorder. I can show, unfortunately, I made several major design mistakes, so it's not functional anymore. But I modeled the actual unit after basically the toy version of the tricorder. Let's make sure we can, yeah, okay. And so I had the toy sitting next to me, and I modeled it. The thing that I'm most proud of, not even the electronics part of it, is inside of the bottom section, these are capacitive touch buttons. So underneath the decal, there's just coils of wire, and those coils of wire are connected to a cap touch sensor back in the on the micro. And there's a speaker down here to play the tricorder sound effect. But I want it to hide the wires between the two. And so I forgot what the name of it's called. I think it's called a blind hinge. But I had to figure out how to design this hinge so that the wires actually go through here so that even when it's closed, you can't see them. That was like mechanically, that was something I had never done before. And
And so, yeah, so it was really fun because I never built anything like this. I did the same thing, same mistake I make every time I 3D print something or design and then print something, is I make the model of what I want it to look like, and then I get so excited I start printing. This is a terrible thing to print because it's all one piece. And so like the mistake I was saying I made is the battery is stuck inside and I can't get to the battery anymore without tearing the entire thing apart because it's not, I should have made it like multiple pieces or something. And so the battery it's a LiPo cell and it's completely, it's a low discharge voltage. So yeah, I was a fan of Star Trek as a kid. I wanted to, I always wanted to kind of make one. I would like to redo this or do this a second version of this and do it much more, I'll say correct, but there's somebody, and I don't know what their real name is, but they go by Mangy Dog or MD around the internet, and they're doing a fantastic job with recreating tricorders that I might just like try to rebuild one of the ones that they've made because theirs are absolutely gorgeous and functional. But yeah, that was one of those. It was kind of a project where it's like I had these 5 parts, and I was really trying to think what could I do with them, and I just decided, okay, I'm going to try and do something I've never done before, which was design something this complex as 3D, and see if I could make something. And I was really happy when it came out, when it was finished. It was super stressful because we were on a deadline, and I was slightly late, but it still worked out.
Yeah, we know those deadline stories. Very stressful.
Yeah.
And Star Trek was very seminal in predicting or perhaps making the future because people copied it. I mean, the communicators that flipped open by the 90s, you had Motorola flip phones, but we're past that level already. And
yeah, actually, I would even argue it's not the same form factor or entirely the same function. But if you think about it, like the tricorder has always been the catch-all device that can do whatever. And so in a lot of ways, especially starting with the next generation, so the Star Trek in the 90s, the tricorder is essentially what our smartphones are now, right? It's our ubiquitous device that can do practically everything we need it to do. Yeah, it doesn't have like a bunch of sensors on it, but we're not that far from, basically our smartphones are what tricorders were.
yeah, I saw a meme the other day, and something a math teacher would have said when I was in high school. I don't regret learning math though, but they would say, you're not always going to have a calculator in your pocket. Well, you say that.
So, okay, I'm gonna slightly one up that one because I remember being told that in school and especially in high school. And then in college, I remember I took a course I took a class it was a class on how to do correct research or something like that. And we had a short couple of weeks of how to search things on the information superhighway correctly using advanced search engines like Alta Vista and finding the right Gopher sites to go to. And I was like, I remember asking the teacher, I said, well, isn't the internet going to eventually replace libraries? And she said, no, of course not. It's not like you're going to have the internet in your pocket. You're not going to have the internet in your pocket. And even then, and that was like, I don't know, that was like 97, 98. I was thinking, yeah, I'm not so sure about that. It didn't pan out the way I thought it would, but I was like, I think we might end up having the internet in our pocket one day. So.
Yeah. And I nearly said a George W. Bush misunderestimated. I underestimated the upcoming mobile internet, even myself in the late 2000s. In the job I had at the time, they proposed, let's make a mobile site so people can buy movie tickets. And I'm like, who wants to go on a phone to buy a movie ticket? I want to sit down at my desktop computer. And well, I got that completely wrong.
Yeah, no, I'm with you. I remember watching my friend buy movie tickets the first time on a phone. It was like a flip phone that had 5 lines of text. It took him like 10 or 15 minutes. And I was like, we could just go there and buy them, right?
Yeah. Facebook at the time, if you took a bunch of photos, not on your phone, we're talking 2006 year maybe, you took a bunch of photos on your decent camera, and you took the compact flash card out and stuck it in a reader and sat at your desktop and then uploaded the whole album to Facebook. It's so great now. You just got the big touch screen, you just share, and it's great for us as people who want to share, but I'm not sure the whole world needs to see everything we have for breakfast all the time. Social media has been a mixed bag, a curse and a blessing. It's
Yep, I would agree
so
with
much
that.
crazy misinformation out there. I thought, okay, internet's going to give everyone information and the whole world's going to get smarter, but people just gravitate toward the information that they want to or that agrees with them.
Or cat pictures.
That's at least harmless, usually.
Yeah, usually.
Let's have a look at another question here.
All right.
Mike Hankey asks, have you looked at or worked with the RC 2014 Z80, Z80 line?
So I haven't, but I'm very familiar with that project. And in fact, when I was designing the Mega 2, the inspiration for my hardware platform, well, it came from the RC 2014. And so this is actually an Apple II computer broken out into individual blocks connected by a backplane. Now, this isn't like a typical computer backplane that was meant for general purpose cards. It basically breaks out the 6502 and the Mega 2 bus. However, the idea of having this kind of cards that plug into a backplane and like that was entirely inspired by the RC 2014. And so that if people aren't familiar with that computer platform, I highly recommend you check that one out. There's all kinds of cool stuff associated with it. As far as I'm aware, it's completely open. But yeah, there's a bunch of pre-existing hardware available for it, and then people are making new cards and peripherals for it all the time. So really cool computer, modern retro computing platform.
Yeah, and I'm guilty of getting involved in projects that I'm probably never going to do, but I recently bought this Z80 retro kit, which comes with a bunch of chips, and it's sitting here, and it's probably going to sit here until I retire, but it just seemed like a cool thing to get at the time. If you look at the currency there, it's probably about $9, so I had to get it.
So I tell you what, Brian, I'm going to give an engineering tip for both you, the audience, and hopefully future me will hear it and remind myself of this as well. So especially the Mega 2 project, I learned that if you want to get something done, have your big audacious goal in mind, but don't make that your only milestone. Every time you look at a project, come up with a milestone you know you can complete the next time you work on it. And so the first one I think we all do a fantastic job of is we buy the parts to do the project. It's like I think we're all very good at that part. But your next milestone should be to organize them. And then the next milestone might be to print some data sheets for them. And then the next milestone might be to connect one or two things together. But start every time you touch that project, even if it's to pick it up to say I'm going to one day get to it, think of what is the next really small step you can do, because then the next time you're like, well, maybe I should play with this, you'll already have thought of, well, here's what I can do with it. And the reason I say that is because with the Mega 2 project, I live streamed almost the entire thing from start to finish. And what I realized is that forced me to think of things I could get done in 3 to 4 hours multiple times a week. And so by having those little milestones, that is so much more important than one day I want to do this. It's no, think about what's the next smallest step you can do, because you're much more likely to do that.
Cool, that's great advice, because I'm surrounded by pots that I buy, and they sit here. But you know, I think I'm remembering when I was in my late teens when I actually had time to just while away an entire weekend just sitting there obsessing over something with no schedule in mind. Baltic Lab has come back to me about participating in that giveaway. He's too advanced for it, but he says he'll pass it on to someone at university if he wins. Okay, good.
Always good to see it going. Always good to see stuff like that going to new potential engineers.
Yeah, paying it forward. Looking at a question about PCBs now, I'll get to that shortly, but I saw in one of your videos you ordered some PCBs and they got delivered to you with shorts in them. on the track before you, I mean, do you normally check the boards when they arrive with the multimeter, or were you alerted to that by a test sheet that they sent you?
Yeah, so that was a whole ball of interesting. So they ended up refunding me the money, but not because they admitted that they built them wrong. So I ordered 3 PCBs, and I got a test report for 4 PCBs, where one of the reports was a duplicate of the other. All 3 boards had entirely different faults based on their I guess is probably a flying lead test or a bed of nails test, and none of the faults made sense. And so when I get a PCB, normally I will check the power rails just to make sure there isn't a major short on the power, just because I'm not going to go through and check everything, but at least I'll check that one because you definitely don't want a short on power. But with that one, with that particular board design, not only so they said they tested 4, they only built 3. They only sent me 3. The only thing that was valid in that whole thing is their test report was correct. The shorts that they found were real shorts. I haven't done it yet, but I really want to sand. It was a 4-layer board. I really want to sand it down because I'm positive on their panel, one of the inner layers had to have been rotated or shifted or something, because there's something wrong on the inner layers that there are nets on that board that aren't anywhere near each other, and somehow they're shorted together. So that was super frustrating. But yeah, to directly answer your question, I don't normally go through an extensive test. I normally just look at the power. Like I said, I check to make sure power isn't shorted and then start populating.
Yeah, I guess it's more complicated on a multi-layer board like you're working on. The only experience I had, have you ever heard of Tango PCB?
That one I don't think I have.
It was DOS-based. I think it was around in the 90s.
Okay.
It's the last thing I used in about the year 2000, and I made these single layer, so much easier. Now, back then, we didn't have people catering to makers where you could have 1 sample board made or 2.
Mm-hmm.
You had to order a minimum of 100, and I only needed like 8. So, I had these all made. I designed this silk screen myself. I was so proud of it. Like, even shows the 7-segment display and the smart card reader, because I was into having a look at chip cards, for satellite TV, purely for educational purposes, of course.
Of course. Yes. I can't think of a
And
single
now
other
I've
way
got,
you use that. You've got plenty.
It was fun, though.
Yeah.
I mean, I'm a pack rat. I'm a hoarder. I've got no use for these, but maybe one day there'll be some use. Maybe I can build a sculpture or something out of them. But it was fun nonetheless. But I really need to up my game. My PCB skills are living in 20 years ago. I need to learn KiCad and make something useful.
I tell you what, I was just at a conference this weekend, a hardware conference. It's called Teardown, and it was amazing to me the range of people in terms of their capabilities with PCB design, and then by extension KiCad and other PCB tools. But I was really thinking about just how far tools have come, because even 10 years ago, most of the tools available to common people, like it was like Eagle, right? And Eagle was a really good CAD tool at the time, but it was still somewhat limited, right? It didn't do a lot of advanced things. It made PCBs, and that was about it. But when you look at to be able to design 8-10 layer boards by yourself with a tool that runs on a regular PC, that's just such a crazy. It's so crazy to think about that. Not that long ago, that was completely implausible, and now anyone can make a PCB. It's not a big deal.
Well, that's the PCB question I was talking about. What do you think the perfect first PCB project should be about?
Okay, I'm going to answer this in an alternative way. Your first PCB project should not be a boost or buck power converter. So don't make your first PCB a switching power supply, because on the other hand, one reason, there's so many things that can go wrong, and it's going to be frustrating to get through them. So I see a lot of people make new projects and they use a switching like a buck converter, and there's a lot of PCB layout things you need to understand how to do before you can do that correctly. That said, I think the most important first PCB project is just one that you can finish. You know, just make one. Nothing has to be fancy. It's completely okay if you want to go and copy one. You know, if you want to go look at like, go and find like a breakout board or like a kit or something and just literally just copy the design, I think that's a good way to start with PCBs, right? Take the whole design process out and just focus on how do I draw the schematic, and then how do I draw the PCB to match something that already exists? Because once you get the first one done, they become so much easier after that. So I think the first PCB design should be either something simple or copy something that already exists.
Yeah, and that's good advice for me too, because as I said, I want to get back into that. It's nice to have something physical that you actually design. James, I could go on for another hour or two with you, but I see we're coming up on our time.
All right.
Is there anything else you want to share before we wrap up?
Something I will say, because I know a couple, or I recognize some of the names in chat, and so I just wanted to thank people that have helped me with some of the projects that I've worked on in the past. I don't always get a chance to say thank you. There's very few things I work on in isolation, and so I just want to make sure everybody knows that if somebody's answered a seemingly random question from me or helped me with something, it hasn't gone unnoticed, and so I just want to say thank you to everybody for both helping and supporting some of the stuff that I do.
Well, that's awesome, and you're doing a lot and contributing a lot. A very productive guy, and thank you for joining us, for giving us this hour, and all the way from Chicago, so it's early in the morning there. And thank you to everyone who joined us from around the world. I've seen Belgium, I've seen the United States. As always, we have a global audience and a global show, and that is a wrap for today's show. Thanks again to our special guest, James Lewis, the bold engineer, who is bold, I'm not sure by choice or by accident, but he shared his expertise and insights with us. And we hope you all enjoyed the discussion and found it as interesting as I did. Don't forget to check out James's YouTube channel and also his blog, boldengineer.com, where you can get all of his links for everything he does. And good luck to everyone who entered the giveaway for today. And those who win, enjoy your Practical Electronics Crash Course bundle. So thanks for everyone who tuned in and participated. By the way, we'll have a video out Friday, I'm told, about the Crash Course bundle. So stay tuned to Elektor.tv. That will take you to our YouTube channel and see more about that bundle on Friday. So thank you to everyone who tuned in and participated. Stay curious, keep experimenting, and we'll see you next time on Elektor Engineering Insights, where we get to meet the maker again, and hopefully we'll have James again sometime in the future, because I have a lot more questions that I haven't asked. Thanks again for joining us. Cheers, and goodbye to you, James, and goodbye to our audience.